Hello, algebra students. Mr. Lawrence here, and we're going to go over this exponential growth and decay equation. Those of you choosing to not watch the video, well, you're just not going to know how to do it. I don't know what to tell you. Those of you that are willing to do your best, I'm proud of you. Keep up the good work. Remember, push yourselves. Try. Do your best. Don't just sit there and think you don't know. You can figure it out. Okay. Let's go quickly over what everything means again. Remember that T is our time, but specifically it's in years. In years, okay? It's got to be in years. R is our rate, but it's as a decimal, so we take the percentage and we divide by 100. Okay, P is our principal or our starting amount. And A is our ending amount, okay? Maybe it's the amount after T years, okay? Ending amount. Okay, so let's see how this works. We're just going to do two quick problems. If you invest $5,000 for 4 years at 3% interest, how much money will you have at the end of the year? This is a pretty vanilla problem. First of all, 4 years, that's T, right? This divided by 100 would be 0.03. That's R. We're investing, which means we're putting money into a bank or a stockbroker or something like that, the stock market. And so this is going to be the amount we start with. This is our principal. All we do is take our equation and substitute the values in. A equals P times 1 plus or minus R as a quantity to the power of T. Now, I want to know how much money I have in 5 years. That's my ending amount. That's A. Okay, the principal is $5,000. 1. The money is growing, so I'm going to do 1 plus 0.03, and I want to do it for 4 years. Okay, let me get my graphing calculator up. Okay, my graphing calculator is up and running. Let me bring it over here, and let me see if I can get it to where I can type in. So I'm going to go 5,000. I'm going to start a quantity. I'm going to do 1.03. Oops, it doesn't like the decimal point. I always forget about that. So let me go back here. Second, insert, and put the decimal in. Now some of you are saying, Mr. Lawrence, why didn't you put a plus there? Well, I just added 1 plus 0.03 is 1.03. Okay, close my quantity, and I'm going to raise it to the 4th power. And there we go. So at the end of 4 years, I will have $5,627 and about 54 cents. Okay, that's pretty vanilla. Now, had I been losing money, let's pretend that we had been losing money. Well, I could do the same equation. Let's keep everything the same, but let's say we were losing at a rate of 2%. Okay, we made a bad investment. We've been losing money. So 1 minus, second, insert. Oops. There we go. I want to do 2%, right? Okay. For 4 years. So now I could have typed 0.98, but I could also type it that way. And when I do that, there. So if I'd been losing money for the past 4 years, I'd be down to $4,611 and about 84 cents. By the way, it's money, so when we're rounding, we should always be rounding to the nearest hundredth, right? Just because of the context. All right, let's take a look at one that's just a tiny bit different. Excuse me. All right, my music seems to have stopped. Something is wrong here. Refresh that, see if I can't get it to start again. All right, meanwhile, people are moving out of polluted town. Imagine that. At an alarming rate. Today, the population is 10,000 people. If people have been leaving at a rate of 9% per year, what was the population 5 years ago? Now, there's a really cool way to do this. This is the way I do it. And one way I do it is I'm going to call this A, because this is my ending amount. This is the amount I have today, and I'm going to go back in time. Or I'm thinking about today. I'm ending with 10,000 people. Okay. And I'm not starting with 10,000 people. I'm trying to find the starting amount. So I don't know P. Now I'll do 1, and it's been losing people. So do minus 0.09, because remember I got to take this and divide by 100. And it's going to be the 5th power. This is how I traditionally have always done it. And I'm going to simplify it a little bit. 10,000 is going to equal P times 1 minus that would be 0.91 to the 5th power. And I'm not going to crunch that big decimal because then you're going to round, you're going to divide, it's not going to come out right. I'm going to go like this. I'm going to isolate P by dividing by the number, keeping P from being alone, right? Okay. Excuse me. And then I can go to my calculator. And let's see here. There we go. So I'm going to have 10,000. And I'm going to divide that by the quantity of, and it doesn't like my decimal point, 0.91. And I'm going to raise that to the 5th power. And there you go. 5 years ago, there was approximately 16,024 people. You could round up to 25. You would not say 24.8 people. I mean, what did, they lop off somebody's leg and say, hey, it's 80% of a person. No, of course not. So you can round, okay? But a few years ago, and it's been a few years now, the students are probably about 26 or 27. I'll bet they're doing really well. Ben Krieger comes to mind. He said, Mr. Lawrence, I think about this problem differently. He said, 5 years ago, sounds to me like a negative number. He said, I want to do it this way. I want to call 10,000 P. Okay? So he went A equals 10,000. Okay? That's P times the quantity of 1. We're still losing people, so that's not going to change. 1 minus 0.09. But since we're going back in time, my T should be negative. And it bothered me at first. Okay, we tried it. So let's do it on the calculator here. We have 10,000. And we're going to multiply it by 1 minus 0.09. And we're going to raise it to the negative 5th. Right? And he did it. And look at that. He gets the same exact answer. So mathematically, it's sound. So I started to think about it. I started to think about the equation. Check this out. This is pretty cool. Okay, so you have A equals P times 1 plus or minus R to the power T. What happens if you divide by this quantity? Okay, 1 plus or minus R to the T on both sides, right? And so then P ends up equaling this equation, A divided by 1 plus or minus R to the power T, right? Don't let all the variables mess with you. It's not a big deal. But remember, I think it was Wednesday in class, we were talking about like 7 to the negative 2nd, and you said, hey, that's 1 over 49. Right? Well, what if I had 1 over 7 to the negative 2nd? Wouldn't this move up to the numerator and become 7 to the 2nd, which is just 49? So what Ben was actually doing then, he was saying, hey, Mr. Lawrence, I want to move this to the numerator. So I'll have my A, but then I'll have the quantity of 1 plus or minus R, and since I move it to the numerator, the sign on the exponent has to change. And there you go, a negative T. And that's all he was doing. Pretty insightful. Okay? You guys are smart enough to think about this stuff. You just got to spend some time. The more you think about math, the more you'll think about it. If you're just trying to get the problems done, you're not going to get the little intricacies. Make sure you're thinking about it, looking for patterns, looking for things that don't seem obvious. At first it seems impossible, but the more you do it, the more you'll start to see, and then the more you'll want to do it, because you'll feel smart, you'll feel intelligent. All right, that's it for the video. Oh, I do want to address, Andrew Zanich raised the point that, for problem 24, through 27, we need to use a graph. Well, I don't want you to use a graph, but look at problem 23, and I lost my mouse. Problem 23 gives some important information, okay? Problem 23 in your book says the population of a metropolitan area was, in 1998, 361,280. Okay, they tell you it was decreasing at a rate of 0.01% per year. Now that's a percent, that's not what R is, right? I shouldn't do that. Okay, we need to divide 0.01 by 100, right? Because we don't want the percent, we want the decimal. I'll leave that up to you. Okay, and then in 24, 25, 26, 27, they ask you to calculate the population in given years. Well, in 2000. Okay. Hold on one sec. Okay, so from 98 to 2000 would be 2 years. And so when I go to do this problem, uh-oh, dead mouse. Quick, get the exterminator, a dead mouse. There we go. Okay, so when I do this, I'm just going to go A equals P times the quantity of 1 plus or minus R to the power of T. And I know that T is going to be 2 years, 98 to 2000. I know that the starting is 361 to 80. I'm losing 0.01 divided by 100 is going to be 1. Alright, no, one more I think, right? Decimal point is here, divided by 100, yeah. Okay, so it's going to be 1 minus 0.00. Alright, hold on a second. What's bothering me is the answer key. I just took it out of the book and it's wrong, unless I'm misreading it. Oh, I am misreading it. Here's my mistake. Okay, everything's good. I was just misreading it. You know, don't assume the book is wrong. The rate was 0.1%, 0.1%, and so when I take 0.1 and divide by 100, I will get 0.001. Yeah, that looks a lot better. Alright, so I'm going to subtract 0.001, and then I'm going to raise it to a power. Now it's 2 years into the future, so it's a positive 2, and that will equal A. And that's what I'll input into my calculator, okay? Make sure you always take the percent and divide by 100 to get the decimal or the rate. Alright, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.